All right, ladies and gentlemen, we're getting into some interesting things where we have to deal with roots and radical expressions. And what better way than to show you a bunch of tables with numbers on it. All right, so here we go. How to read this table. All right, these numbers right here on the left side are all the exponents. So if you see this 6 right here, it's because every number is being taken to the 6th power. And that's what you get. All right, so here, this is the 2 table, this is the 3 table, because those are the bases. All right, the exponents are over here. These are the bases down here, 2, 3, 4, 5, and 6. Those are the base numbers. Now, if I wanted to know, let's see here, what is 4 to the 3rd power? Well, I'd look right here. 4 to the 3rd power is 64. If I said, okay, what's 5 to the 5th power? That would be 3,125. Now, you could always use your calculator. Your calculator has a button on it that has a caret. So if you wanted to do, let's say, 2 to the 4th power, you type in 2 caret 4, or some calculators have a X to the Y button or Y to the X button. Either way, this would be a good idea. It would be a good idea to look at your calculator and try and figure it out, or even your phone if that's what you're using as a calculator. Now, these are the bigger numbers. So if you wanted to figure out, let's see what 8 to the 4th power is. Well, that's 8 to the 1st, 8 to the 2nd power is 64, 8 to the 3rd power is 512, so 8 to the 4th power would be 4,096. So that's how you read these tables. Once again, the base here would be 7, here's the base is 8, base 9, base 10, base 11. Okay, now if you want to see a bigger table, here you go. This takes you all the way from 1 all the way up to 10 with these bases. So hopefully that's helpful to you. But the real reason I'm showing you that is so we can start talking about roots. Now, we've dealt with roots before, but we've dealt mostly with square roots. So if I said the square root of 49, okay, well, that's the same thing as 7. But how you look at this is, well, 7 squared is equal to 49. So the square root of 49 is 7. Now, you might not know this, but the reason it's called the square root is because there's a little 2 right in there, okay? And if you're ever writing these down, this is a root, all right? This is long division. So I don't want to see any of those in here, all right? No long division. We're just taking roots. Now, let's talk a few more examples of the ins and outs of these. If I had 4 to the 3rd power is equal to 64. Well, that is similar to saying the 3rd root of 64 is equal to 4. All right. A couple more examples. If I had 5 to the 4th power is equal to 625, then I could deduce that the 4th root of 625 is 5. So we're going forwards and backwards with these. We'll do one more example. The biggest one that we'll need on the last problem. So 2 to the 7th power is equal to 128. That means I could say the 7th root of 128 is equal to 2. So we're going forwards and backwards with these. Hopefully it's not too crazy for you because we've dealt with roots before. Like if I said the square root of 36 is equal to 6, then 6 squared is 36. So just working in and out. And there's an imaginary little 2 in there. So let's start jumping into these. Now, I do have some notes over here to the side that are going to be, it should be super helpful. Hang on, let me get my pen going. There it is. All right, I just can't write over here. There I can write. These are all notes, okay, that I stole from my own slides. So when you start with this, the first thing you look at is the radicand right there, the number inside the root. So since I'm taking the 6th root, I need to find a good 6th root. So I know that 2, and this is the one we're going to be using mostly, the number 2 to the 6th power is 64. Okay, so this is what I'm going to see. I'll say, so let's see if 64 is a factor. What is 320 divided by 64? Well, 320 divided by 64 is 5. Cool, that means this. The 6th root, now 64 is also the same thing as saying 2 to the 6th times 5. All right, well, the 6th root of 2 to the 6th is 2, so 2 pops up. Now, that 5 can't go anywhere because it's not a 6th root of anything. So then I write 2 the 6th root of 5, and that's how you say it as well. 2 6th root of 5. These are being multiplied for the record, just so when we get into the more difficult problems later, you know what's going on. But that's it. That's how you simplify that radical. And yes, this is the work necessary. It would be really easy just to plug this into some of your calculators and get that. You need to know the two factors that you're using to get full credit. Thank you very much. Now, we're talking about the fourth root of number 2, the fourth root. So I'm going to look over here at the fourth. Now I have 3 to the fourth is 81, but I'm gonna stay right here. All right, because I can say that 128 is the same thing as 16 times. It's not 4. Is it 8? Yeah, it would work. 6 times 8 is 48, and then yeah. Okay, so since I know 16, now 8's 2 to the third, but that doesn't matter to us. All I need is that good fourth root right there. So this is the same thing as the fourth root of 2 to the fourth times 8. So this is the same thing as 2, because the fourth root of 2 to the fourth is 2, and then the fourth root of 8. Now you might be saying to yourself, well, 8's right here. It's 2 to the third. Can we do something with that? Well, if you have the fourth root of 2 to the third, those don't match up. So you can't do anything there. Doesn't work. Now, technically, and moving forward, this is exactly what happened here. We knew that 2 to the 7th power is 128. Okay? So when we're taking the fourth root of 128, that's the same thing as saying the fourth root of 2 to the 7th. Well, that 2 to the 7th can break down. You can break down into 2 to the 4th and 2 to the 3rd, because 4 plus 3 is 7. So now we took the fourth root of 2 to the 4th, and that 2 popped out, but then we still have the fourth root of 2 to the 3rd. Well, to simplify it, 2 to the 3rd is 8, so this is 2 and the fourth root of 8. So that's how we ended up getting there, just a different way, okay? Now, over here, I'm taking the fourth root of 128, or the fifth root of 128. So now let me change the color so you know which one I'm working on. This is the same thing as the fifth root of, let's see here, fifth. So 32 is a good one to start with. And it'd be 32 times 4 for 128. All right, so I just took 128. I figured that we might be using this, so I divided 128 by 32 and got 4. So now, this is the fifth root of 2 to the 5th times 4. Well, the fifth root of 2 to the 5th is going to be 2. Those basically go away, and you're left with 2. But now 4 stays in, but I have to remember to have the 5 on the outside. So that would be that radical simplified. All right. And last but not least on this one, I'm going to start taking the third root. Now, I do see that we could probably maybe get an 8 to go in, but since I know what I'm talking about here, I'm going to look at this one right here. Because 3 to the third power is 27. All right, so this is the third root. Let's say 27. How many times does it go into 162? Maybe, so 6 times? Maybe? I don't know. It's 162 divided by 6. How many times is 6 going? 16, 2, that's 12, 4, 2, 7. Yeah, there we go. So, the third root, this is the third root. Now, 3 to the third power, which is 3 times 3 times 3, is 27. All right, that's where we got that. And so the third root of 3 to the third is 3. So 3 pops out. The third root of 6, can't do anything there, so we just leave it the third root of 6. And that's the first 4.